Welcome to LIB Academy, and I'm going to teach you how to use the shortcut method to evaluate gamma functions. So how do we evaluate gamma 11 on 2? Well, it turns out that I know your mind will come on these two formulas. Yes, this formula is used for fractions, and this formula is used for numbers that are not fractions, right? Or non-fraction problems. So when you are to find a gamma of something, if the term or the argument is a fraction, your mind should come on this formula. And if it's not a fraction like these ones, your mind should come on this formula here, the one that involves factorial here. So before we continue with the fraction, I know you know that for gamma 7, you just subtract 1 from 7 and take you just subtract 1 from 7, remaining 6, right? Then you take 6 factorial. Or that is the answer. When you evaluate this on your calculator, what you get is the value for gamma 7. And for gamma 1, that is a constant. Gamma 1 is the same as 1. So we are done with gamma 1. And gamma half 2 is also a constant. That is square root of pi, right? So any problem of this form, let's say gamma 8, you subtract 1 from 8, remaining 7, you take 7 factorial. Gamma 10, subtract 1 from 10, giving you 9, so 9 factorial. What you evaluate, I mean, if you put it on your calculator, what you get to be the value for gamma 10. So now, gamma 11 on 2. And we know that for gamma 11 on 2, we are using this formula because it is a fraction equal n gamma n. So we are trying to express 11 on 2 in the form of 1 plus something to give us 11 on 2. And we don't know that one. Now that we have to follow a long procedure to look for that number, let's say we want something to add to 1 that will give us 11 on 2. So n plus 1 equal 11 on 2. So n plus 1 equal 11 on 2. So n equal 11 on 2 minus 1. So subtracting 11 on 2, subtracting 1 from 11 on 2 gives us 9 on 2. You can see that this one is somehow very tedious. You are going to go a long way if you have a certain problem, particularly for 11 on 2. So now that we got a certain number plus 1 minus plus 1 should give us 9 on 2. Our n is what? Our n is 9 on 2. So it means that 9 on 2 plus 1, I mean gamma 9 on 2 plus 1 is the same as gamma 11 on 2, right? So now that we have this one like this, then we'll now compare it to the formula here. So apart from 1, this is our n and this is our 1, right? So we say it's equal to n factorial gamma n. Sorry, it's equal to n gamma n. So this means that gamma 11 on 2 now here equal 9 on 2 and gamma n 9 on 2. So what you want to do is that you continue doing this up to a term that when you are trying to go further, you get a negative value or you get a constant which is half, then you stop right there. So let me now show you how the trick comes in. So I'll just tell you that you have to find gamma 11 on 2. So point gamma just point 11 on 2 on your calculator. So now you point 11 on 2 on your calculator. Start subtracting 1 from it. Whatever you get, you write. 11 on 2 minus 1 gives me 9 on 2. So 9 on 2. Start subtracting 1 from it. Minus 1 again gives me what? 7 on 2. 7 on 2. Minus 1 again gives me what? 5 on 2. 5 on 2. Minus 1 again gives me what? 3 on 2. 3 on 2. Minus 1 again gives me what? Half. Minus 1 again. You see, when you are going further, you get negative number. Then you stop right there. You stop at where half, then add gamma half to it. So now what we have to do is that it means that gamma 11 on 2 equal to 9 on 2 multiplied by 7 on 2 multiplied by 5 on 2 multiplied by 3 on 2 multiplied by half gamma half. So like I told you that you want to get to a point where you can get a constant, or if you are trying to go further you get a negative number, then you stop right there. Or better still, if you want to go further. So now multiplying all these here will give you 9, 4, 5 on 3 on 2. Then we know that gamma half is a constant, which is square root of pi. So that is it. You can definitely use this procedure to find gamma of values like this. Because you see that doing this one after the other is going to take much time. So thank you for watching. See you in my next video. I have full videos and full lectures on gamma and beta functions. You can also check them out.